Hi, good evening, students. Welcome to this session on NMTC preparation. So, we are going to be discussing all different types of problems over the next 3 weeks, and hopefully that will prepare you for NMTC, and hopefully you will do well in the first stage of the examination. Today we are going to be discussing geometry, and mostly in geometry we are going to be discussing areas. Okay, so those who are in Zoom, if you can do turn on your videos, it would be nice to see you. And those who are in YouTube, you can respond on the comments. I will be responding to your comments. Kindly do discuss with me as we solve these problems. Okay, so my approach is going to be mostly problem based. So we are going to solve a bunch of questions, and so that I can gauge how much you understand in each of these problems. And in case you don't understand, kindly put it on the chat, or you can use your audio. But I will need you to respond to me via audio during the class. Okay. So, okay, great. So let me just a minute. Okay, let me start with problem number 1. We are going to start with the first problem. I hope you can see the first problem.
Yes, sir.
Yeah, okay. So there is a square ABCD, okay, and point E lies on this side AD. So this point E lies on this side, okay, and F lies on this side BC. So that BE is equal to EF. So this length BE is equal to EF is equal to FD, and each of these are given to be 30, and you need to calculate the area. So let's try this. Would anyone be interested to make some initial observations regarding this problem? What do you see? Any observations are good. Pratham, do you want to make some observations? Anything? Do you see anything here? Do you see anything in this problem any observations regarding this problem? They're given this length is equal to this length is equal to, sorry?
There are triangles.
Triangles, okay. You can see a couple of triangles here, right? Okay. Yes.
Sir, if this is a square, then DC should be equal to AB, right?
BC should be equal to AB. That's right.
No, sir. D.
DC, yes. All sides should be equal,
Yeah,
right?
all sides should be equal. I'll explain from that side. DC is equal to AB.
Right.
And we know that the length of BE is equal to length of sir, length of BE is equal to
This,
length of EF.
yeah. All these lengths are equal, right?
So we can safely tell that triangle EAB is congruent to triangle DFC.
These two triangles are congruent. Okay.
And the other two should be naturally congruent because
These two
you
also
told that
be
the diagonal line is same and the sides are also same.
So, how do you know that the first of all, how do you know that these two are congruent?
So the angle A and angle C are 90 degrees.
These are right angle, correct?
Yeah.
The opposite sides are equal.
Opposite sides are equal and the hypotenuse is also equal.
Hypotenuse is also equal.
So
Good.
if we apply the Pythagoras theorem also, we'll get EA and CF will be equal because the other two values are the same.
Okay, let me just write.
This is congruent criterion.
DC is equal to AB. Hold on. DC is equal to AB. Angle A is equal to angle C. Okay, and what else do we have? DF is equal to BE. Right. So we have all of this, and so yeah. Just a minute. So these two triangles are congruent. Which triangle? Triangle ABE is congruent to triangle CDF. Right. Then what else do we do? We know these two triangles are congruent. Okay. And here also these two lengths are equal.
Sir, even those two triangles are congruent, DFE and BEF.
Why so?
Because we know that the DF is equal to EF and EB. Those three lines are equal.
These lengths are equal to these lengths. Fine. And what about the bases? Are they also equal?
Yes, sir, because EA is equal to CF.
Good.
So the remaining should be.
These two are equal because they are congruent, these two triangles, and therefore the remaining sides, which is DE, should be equal to AB, and therefore these two are also congruent. Good. So now we have found that these two are congruent. I have not written this down, but you can make that observation that this triangle is congruent to this triangle. Okay, good. Now what do we do? We need to find the area. Area means if you find the side length, you can find the area, correct? So somehow we find the side length. How do we do this?
First, we can find the area of the triangles in between over there.
Okay, so how do we do that? We have this to be 30, this to be 30.
30 centimeters, yes, sir.
But how do we find the area of this triangle now? Nothing else is given.
So can we find?
I think the base is x, sir, or some variable, so half into base into height.
Okay, so you want to take what as x, Varshini? Which length you want to take as x?
One unknown length.
Not sure. Shall we take CF as x? Let's take this length as x. Okay.
Sure.
Request you to kindly raise your hands and then I'll call out your name. Then you can answer. Okay. Yeah. So now I've taken CF as X. Now I've started with Varshini and Pratham, so you guys can complete this problem. What will be this F? What will this length be now? Can you
It
guess?
will be the total length, total side of the square minus x.
In terms of X, can you guess how much will this be?
2x.
Why so, Samit?
Because, like, if we draw the perpendicular line from E to the CB line.
Okay, you want to drop a perpendicular from here to here. Okay. Then what will happen?
Sir, in that case, we'll get two more triangles which are congruent to our first triangle DCF.
Very
so
good.
we know that the base of DCF is equal to x. So
Correct.
naturally, the base of f.
This triangle also will be congruent to this triangle. Why?
Yes, yes.
This angle is 90 degree. These sides are equal, right? And these sides are equal.
Yes.
So you'll get them to be congruent. Right? So now, similarly, since this length is x, these two lengths also have to become x. So we'll have this as x and this as x. So totally that lengths are, the side length is 3x,
3x.
right?
Yes.
So what will AB become now?
AB also will be 3x.
3x, right?
So we know that we know the area of the triangle DCF, which happen to base into height. We know its base is equal to x. We know its height is equal to 3x.
Correct. So right. So before that, we need to find out x, right? If we find out x, then we can find the area. But how do we find out x?
So by Pythagoras theorem.
Which triangle?
So for any of the triangles, sir. No, but the x will be 15, sir. It will be half of the. No, sir. It will not be 15.
You're right, Roy. Which triangle, Pythagoras? Some triangle. If you shall we take this
FPG.
FEG? Good. Triangle FEG. This is a right angle triangle. Correct. So this is 90 degrees and this is x. How much is this length EG, Roy?
So 3x.
3x. Right. So you have FG square plus EG square is equal to FE square. Right. So that will give you FG square is how much? FG square is x square plus 3x the whole square is equal to FE square, which is 30 square, which is 900. Right. So this is x square plus 3x the whole square. How much is that? 10. This will become 9x square. 9x square plus x square will give you 10x square. Right? You'll get 10x square is equal to 900. That implies x square is equal to 90. Right? And what about our area? Our area of the square is 3x the whole square. Right? Because each side is 3x. So that is 9 times x square, which is 9 times 90, which is 810. Okay, so the area is 810 square units. Okay, so option C is the right answer. There is a possibility that the options might not be completely right in all the options. So let's see. Okay, I hope you all understood with this question. So the main thing that you needed to see is that these triangles are congruent. I wrote it down here, that's why it took a bit of time, but you could quickly see that they are congruent, and then once you assign any one length as x, you can calculate this and this length, and then you can find the area. Yes, shall we move to the next? Here, question number 2. I'll give you 2 minutes just to try initially, think about it, and then I'll ask you for suggestions. Okay, Raghavendra has raised your hand. Hold on, Raghavendra. Let's give everyone 1 minute and then we can start with you. Sorry, I was not reading the chat till now. I will, from now, I'll be reading the chat. Okay, so you can put it on the chat. Okay, Abhi, you can start. Tell me what is your suggestion with respect to this problem.
We can start, I think, by drawing a rough sketch.
Okay, so let's draw first triangle, which is 25, 25, 30. What sort of triangle is it, Abhi?
It's an isosceles triangle.
Okay, so 25, 25, and 30, something like this. Okay,
Yes.
this is our first triangle. Okay, what about the second triangle?
It's the same thing. It's an isosceles too with the same sides, but it's 40 instead of 30.
So will it be sort of flatter or will it be higher? Will it be something like this?
It'll be flatter.
Flatter, right? Because this length becomes slightly more and this will come slightly down like this.
Yes.
Right? So let me draw that also for you. So this is our second triangle. Okay.
Triangle PQR.
Hold on, Varshini. Let's talk to Abhi. Yeah, Abhi, go on.
Okay. So if we draw the altitudes of both triangles.
Okay. So let's draw altitudes from here and here.
Yeah. So if like the altitude is the midpoint, I mean it's sort of the midpoint of BC where it touches it.
Why is it the midpoint? Why is the altitude a midpoint?
We can prove it using congruence. Obviously, B and C are equal because they are the base angles in the isosceles triangle.
Okay.
Then A, so can you name it D or something, like the point where it touches?
This is E.
Okay, yeah. AEB is 90 and AEC is also 90. So
Okay.
it's 90 and the side lengths are 25 and 25. So it's
these two lengths are angles are same. These two angles are the same.
Yes.
So third angle will also be the same and one side is the same.
Yes.
So therefore they are congruent.
By ASA congruence criteria.
Right. ASA, they will be congruent.
By CPCT, BE is equal to EC.
Okay. BE and EC will be equal to 15 each, right?
Yes.
Similarly, these will be equal to 20 each. Right? Here?
So now yes.
Okay.
Using the Pythagorean theorem, we can find AE.
Okay. So what is this length here? AE? How much will it be?
It's 625 minus 225, which is
if you usually Pythagorean triplets, see these are multiples of some number, right? 25
yes.
and 15. They are multiples of what?
Okay, it's a 3, 4, 5 triplet.
Yeah. So 25 can be written as 5 into 5.
So it's 20.
Yeah. So 25 can be written as 5 into 5. 15 can be written as 5 into 3.
So that
and
is 5 into 4.
This will be 5 into 4.
Which is 20. Yes.
I hope others understood this. You know that 3, 4, 5 is a Pythagorean triplet, right? In a Pythagorean triangle, if you have one side as 3, one side as 4, the other side will be 5. And any multiple of 3, 4, 5 will also be a Pythagorean triplet. So you can have 6, 8, 10, 9, 12, 15, which is each of this here I multiplied them by 2, here I multiplied them by 3. Okay, so any multiple of a Pythagorean triplet is also a Pythagorean triplet. Okay, you can prove that. But anyway, coming back to this problem, we have, instead of taking 25 square minus 15 square, you can just see that this is 5 into 5, this is 5 into 3. So this 5 into you leave, you'll have 5, 3, and therefore the third side has to be 4. Okay, so similarly here, this is 5 into
5.
Yeah, 5 into 5. This is 5 into 4, and therefore this
That
will
is
be
5
5
into
into 3. Good. And now we can calculate the areas, right? How much is triangle ABC?
It's 30 into half into 30 into 20, so it's 300.
20, which is 300. Good. What about
That
this?
that is half into 40 into 15, which is also 300. So
Which
A
is
is equal
also
to
300. Very good. Therefore, the areas are the same, and we have both the areas to be the same. Option A. Good. Are there any doubts with this? Any clarifications? You can ask me if there are any doubts, any clarifications. Third question. This is slightly simple, so I'll just leave it to you. You can tell me the method and you can do it at home. Okay, read the question. Total surface area of a cube is 600 square centimeter. The length of its diagonal is.
Sir,
Yes.
we can find the length of each side and then apply the Pythagoras theorem and find the diagonal.
Okay, so how much is the total surface area of a cube?
6L
If the side,
6L square.
right. If the length is A, it is 6A square. So 6A square is equal to 600. So you'll get A is equal to 10, right? So side length is 10. Now, how do we find the length of the diagonal? The diagonal, Pythagoras theorem. It's not the diagonal of the side. So if you look here, this is not the diagonal we are looking for. The diagonal we are looking for is from one corner to the opposite corner. Okay, so it will be something like this, from here up to here. Okay, so how much will that be? Any idea?
Sir, let's first find the length between the two opposite corners of the bottom face using Pythagoras theorem.
How much will that be?
I found that the length of each side should be equal to 10 units.
Correct. So this is
So
10.
if we
This
try
is 10.
Pythagoras theorem,
Correct.
then we can.
How much is that? Did you calculate? Okay, let's calculate. You'll get diagonal of the face square is equal to 10 square plus 10 square, right? From Pythagoras, which is 100 plus 100, which is 200, right? And so this diagonal of the face of this face, this diagonal, the length is root of 200, which is root 2 times 10. Okay, so we have found this length. How do we find from here up to the opposite end? How do we find that? Pratham, continue.
Sir, after we find the distance between, sir, we have to know, sir, of the bottom face.
Same thing. This will be same also as the bottom. Okay, so you have found the bottom.
We'll find the bottom side, and now the height is equal to 10.
This is also 10. Good.
10.
This length is 10 root 2. We just calculated here. This length is 10 root 2. This length is 10. And therefore, this diagonal, again, we will get Pythagoras theorem here. Okay. Again, this is a right angle triangle.
Sir, or we can directly use the formula, right?
Yeah. If you know the formula, well and good. Otherwise, the length of the diagonal is again 10 square plus 10 root 2 the whole square, which is 100 plus 200, which is 300. And therefore, the length is 10 times root 3. Okay. This was a slightly easier question.
Scroll a bit up. I was just noting it down.
Yeah, here you go. Okay, let's go to the next question. We have this figure. The distance between any two horizontal or vertical dots is 1 unit. So each of these distances is 1. Okay, you need to find the area of this triangle.
Sir, we need to apply the Pythagoras theorem here also. Find the length of the base. Like if we take one of the sides as the base, then we can apply
Hold
the
on, Pratham. Let's see. Let's ask others also. Okay. Hold on. Put your suggestions on the chat, whatever it is. Anyone else wants to give it a shot? This question.
Yes, sir.
Yeah, Roy. Roy, any suggestions? Can't hear Roy. Is there anyone else who wants to try?
Yes, I just now got disconnected, sir.
Okay.
Each of the sides are actually hypotenuses of a right angle triangle.
Correct. So side lengths we can calculate, right?
Yes, sir.
So this side length is hypotenuse of this big triangle. So here 1, 2, 3, 4. This length is 4. This length is 3, and therefore this length will be 5. Okay. What else? And other two lengths also we can find similarly. Then what do we do? This is 4, this is 2, so root of 18, this will be, sorry, root of 20, that is, how much is that? 2 root 5, 4 root 5?
Sir.
2 root 5, right?
Sir, isn't it 3, sir? The base is 3.
Base is 3, sorry. So 9 plus, this is 9, this is 9, plus 4, that is root 13, and this is root 2. Then what do we do? Does anyone know any formula with respect to sides?
So Heron's formula.
So can you tell how do you get the root 13 and the root 2 again?
Yeah, sure. So this, if you look at, this triangle here, this triangle, this side length is 3, this side length is 2, right? So the hypotenuse square is root of 3 square plus 2 square, which is root of 9 plus 4, which is root 13. Similarly, the other one. Okay, but there is Heron's formula, but now we have square roots, root of 13, root 2, which are irrational numbers, and getting them into Heron's formula will complicate the question quite a bit, right? We'll have some big multiplication to do.
Sir, sir, what if we divide, we can think this, we can join the outer dots and form a rectangle.
You want to join the outer dots. Let me name these points, then that will be easy. A, B, C, D, E. Okay. Which points you want to join?
Sir, A to D and D to B and D to E and E to A.
Okay. So let me join this. This will become a rectangle. Okay. Fine. Then?
Now we can find the area till like we can draw, we can continue AC and we can make it intersect B. B.
You want to continue, you want to extend AC and let it intersect BE at some point. Okay. Then
we can find the area of that triangle, and then after that we have to find the area of ABE.
which triangle you want
First
to find?
we have to find the area of ADB.
ADB. Yeah, that is easy.
Sorry,
Right.
AD, not ADB, sir. ADF, the new triangle.
ADF.
Sir, can we just do half into base into height for this ABC, sir?
But what's the height? Where's the height? Base, if you take this as base, this will be the height, right? But how do you calculate this height? Similarly, if you take this as base, somewhere here will be the height. But how do you calculate this height?
Oh.
Good observation. Even Pratham, see, if we take this base, if you want to calculate this triangle, again this length we don't know, right?
Sir, I didn't want to do like that. I want to divide this entire rectangle into two pieces.
Okay.
And the common area where the I want to divide it in such a way that there will be a common area, which will be the triangle along with CBF.
Along with CBF, is it?
Along with CBF, we can AB, sir, AB and ABF triangle should be the common area between AD and B and the new triangle which we have to form. Then we can subtract those two triangles to get the area of ABF.
Correct, but these triangles are also not known, no? Okay, so let me just give you a hint. So we have this big triangle. Maybe, as Pratham suggested, we can find some big triangle and then subtract some areas, and we may get our answer. We can definitely find this triangle, right? AEF is very easy to find the area of this. Now we want just ACF out of this. Is that hint helpful?
Sir,
We need ACF, right?
Sir.
Anyone else? Sasmit, do you have any suggestions?
F also into a triangle, right, sir? Like two triangles.
Where?
Joining ACE and ECF.
No, that won't help, no? Unless you have some lengths and unless you can calculate the area. Here, why can we calculate the area? Because we know this is a right angle and these lengths we know. This is 4, this is 3. So half of 4 into 3 will give us the area.
But if we divide CE, sir, like into ACE, it will be like...
But there's no right angle here, no? In ACE.
Oh, okay, sir. If there was right angle, then we could find out.
Right, right. So can you think of some other division where we sort of get right angles, and then maybe we can get the answer?
Sir, we
So
can.
like we'll get a trapezium shape, I feel.
Okay, where do you want to divide?
How do I shall I annotate, sir? How
Yeah.
do I annotate? Like
No, you can tell me here.
like from that from A, the next point from A.
Okay, so G. Okay, here.
No, sir, from A.
Here, this side.
No, sir, from the end point A, the
Okay.
right side of it.
I, J, K. Okay.
From I, let's draw a line, a straight line to. No. To the to our triangle thing.
Here, perpendicular.
Yeah.
Okay. But we don't know this length, no? Again. You need to know the lengths also.
Sir, one more idea, sir.
Yes, Pratham.
Sir.
Sir, can we draw perpendicular to G from point C?
Perpendicular to G from point C. Something like this?
Yes, sir.
Okay, so how will that help?
And if we try to extend it a little bit in the top, if we try to extend it.
No need to extend. Why you want to extend? Can you find this area now?
Sir, CK, if we join CK, we'll get another, whatever that is, it's a parallelogram or a rectangle, we'll get.
Okay, you want to join CK also. Good.
Yes, sir. Then we'll get a right angle over there also.
Okay. Do you all see it now? Now we get many portions which we can find out the areas, right? This we can find out the area. This we can definitely find out the area, and this also we can find out the area. So from the big triangle, we have divided these parts, we remove these parts, and whatever will remain, that will give us the area of the triangle, right?
Sir, which means that we can find the area of the bigger triangle and subtract it from the smaller parts which we have made, some of the smaller parts.
Correct. So area of the triangle will be the area of the bigger triangle, which is half of this base, which is 1, 2, 3, 4. Height is 1, 2, 3. So half of 4 into 3. From this, we have to subtract area of this triangle, right? Which is half of 1, 2, 3 base into 2, right? Which is half of 3 into 2 minus area of this triangle, which is half of 1 into 1, which is half, minus area of this rectangle, which is 1 into 2, which is 2, right? So how much will that come to? This is 12 by 2, which is 6, minus 6 by 2, which is 3, minus 2 minus 0.5, which is 0.5, right? That's the area, right? Okay, good. So let's try the next question. So the answer is half. Okay, I hope you understood. Is there any doubt with this now? Anyone? Okay.
But what are that 4 and 3 lengths, sir? Is that of the bigger triangle, sir?
Which one?
The lengths 4 and
3 is the bigger triangle, right?
Yes,
so
sir.
the triangle AEB, okay, that is the bigger triangle. Okay.
Yes, sir.
Understood. Cool. So let's go to the next one. I'll give you 2 minutes. Just try this. Yes.
Sir, can I answer this one?
Yeah, please raise your hand if you have some option. I'll give you 1 minute. Just after that, we'll discuss. Okay. Okay, so I have 5 people who have raised their hands. Let me first read out the question. In the adjoining figure, the breadth of the rectangle is 10 units. 2 semicircles are drawn on the breadth as diameter. The area of the shaded region is 100 units. So the shortest distance between the semicircles. Ninada, let's see, you didn't answer till now. What do you?
Yeah. So first we will take the area of both the semicircles.
How much is that?
So both of the semicircles, I took the pi as 3.14, so 78.5.
Don't take it as pi itself. Let it be as pi itself, because the answers options you see are in terms of pi.
Okay, so it will be then
Pi times
25 pi.
25 pi, correct?
Yeah.
Because
So
this is half, this side is half, the other side is half. So together it is one circle.
yeah, one circle.
And the radius is 5. So
Yeah.
therefore together it is pi r square, which is
25 pi.
25.
5 into 5, 25, then 5. So
Right.
then since you have found 20 this, so 25 plus 25 pi plus 100 will be equal to the total area of the square, I mean rectangle.
25 pi plus 100 will be the total area of the rectangle, right?
Yeah.
Because 100
then,
is the shaded and 25
yes,
pi is the unshaded.
unshaded. Then we will find the length, the total length of total length of the rectangle.
Okay, so let me just write down. You said the area of the circle is pi r square, which is pi into 25. So 25 pi plus 100 is equal to area of rectangle, which is length into breadth.
Yes.
Right.
So after this, you will get the length.
I hope this is clear to everyone. Is there any doubt till here? Both of this make a circle, right? So one area of circle is pi r square and diameter is 10, therefore radius is 5. So we'll get pi into 25. So
Sir,
that,
and we know that the shortest distance between them will be like if you connect their like the midpoint.
centers, right?
Yeah.
Right.
Yes,
So
sir.
first,
And we know
but
their
first we need to find the length, right? We need to
yeah.
find the length. So length will be how much? This will be, divide the whole thing by 10. You'll get 10 plus 25 pi by 10, right? That will be the whole length.
Yeah.
Now, what do we need? We need only the shortest distance.
So since each of the semicircles will have 5 and 5 centimeter.
Correct. So
like
this
the radius.
is
So
this is
5
5.
plus 5.
This is 5.
We will be able to deduct the whole thing minus 10. So 25 pi by 10 will be the answer.
So from there to there will be the whole length minus this and this, which is 10. So which is this whole length minus 10, which is 25 pi by 10, which is what? If you simplify?
It's 5 pi by 2.
Which is 5 pi by 2. Which is
Sir,
this.
can you repeat how you got this 25 pi by 10? Couldn't hear.
From here, I divided the whole equation by 10. Okay. So RHS by 10 will give me length, right? So this whole thing I divided by 10. So that will give me 25 pi by 10 plus 100 by 10, which is 10.
Okay, sir.
Okay. So just write down this equation and divide the whole thing by 10. It will become clear. Okay. Do it at home. Okay. Let's go to the next one. This is also sort of simple, not too difficult. Just try and get me the answer. Put your answers on the chat.
It's like L square. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8.
Sir, can I answer? Sir?
Yeah, please put your answer on the chat. Okay.
Okay, sir.
Okay, many of you seem to have got it. Let's quickly solve this.
Sir,
Nikhil,
both
hold on, Ninada, hold on. Nikhil, Vikram, are you there?
Yes, sir.
Yeah, let's see. How did you get the answer? Can you tell?
I just divided the whole number of squares by 288 divided by the whole number of squares. There are
288 divided by number of squares. How many squares are there?
8.
Okay, 8. How much is that?
46.
40,
Okay. Yes,
30,
sir.
36, right?
36, sir.
No. So,
36. 46.
correct. So 36 square centimeter, this is area of each square. So how much is the side length of each square? Root of 36, which will be 6, right?
6, sir.
Now you have to find the perimeter. So which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Together there are, if you count this perimeter, it is 16 times the side length. Okay, which is equal to 16 times 6, which is 96. So the option is B. Good. It's an easy question. Good. Good to see your answers.
Just a doubt, sir. Even D is also 96.
What is also 96?
Even D is written as 96.
Ah, that's fine. That's fine. Don't worry about that. Okay, let's try the next one, please. Okay, let's go a bit fast because we don't have too much time. So, okay, ABC is an equilateral triangle. Squares are described. Okay, let's give Roy a chance. Roy, let's see. ABC is equilateral triangle. Squares are described on sides AB and AC as shown. The value of X is. So let me name all different points. D, E, F, G. Go on, Roy.
Yes, sir. Sir,
Yeah.
angle BAC will be 60 degrees. Since
This
it's
is
an
60
equilateral
degree.
triangle.
Okay, good.
Then the adjoining angles will be 90° each.
Right, both of these are squares, so both of them are 90°.
So the total sum of the angles around the point A will be 360°, and the angle A in the other triangle will be 360° minus 90 plus 90 plus 60.
Correct. So this angle, which is angle, sorry,
360 minus 240.
angle CAG is the whole angle minus whatever angles are given here, which is 360 minus 60 minus 90 plus 90, which is 180. Right. So which is 180 minus 60, which is 120. Okay. So this is angle CAG.
Yes, sir.
Good.
Then we
So,
know that it. Then we know that it is an. It is a isosceles triangle, sir.
why is it a
The
isosceles triangle?
Because the sides of the squares are equal.
Sides of the squares are equal means this side will be equal to this side will be equal to this side. But why is this side equal to this side?
Yes, sir. Because they are all because they all have the same side length of the equilateral triangle.
Correct. So these two sides are equal, and similarly these sides are equal because it's a square, these sides are equal because it's a square. Therefore all these 8 sides together will be equal. So this side and this side also will be equal. And if these two sides are equal, these two angles will also be equal, right? So go
Equal,
on.
sir. Yes, sir.
So area, so in triangle
So then
ACG.
So 30°.
In triangle ACG, what will happen? Go on, Roy.
Triangle ACG plus triangle AGC will be equal to
angle 120 plus x plus x.
180°
Right?
minus 120. Yes, sir.
Totally will be 180°.
180°. 2x is equal to 60°.
X is equal to 30°. Very good. Nice. I see that others also got the answer on the chat. Good. Try the next one. ABCD is a trapezium with AB is equal to 6, AD is equal to 8, DC is equal to 18. The sides AB and CD are parallel. Okay. Of course, if angle A and angle D are perpendicular, AB and CD has to be parallel, right? Correct. So now P is the point of intersection of the diagonals AC and BD. The difference between the areas PCD and PAB in square centimeters is. I'll give you 1 minute, then I'll ask you to raise your hands. Okay. Okay, raise your hands if you thought of some approach and you want to share that with me. No need to find the solution, but if you think of, you have some approach in mind which I could try. Yes, Ninana, tell me.
So first what I would do is I would calculate the area of ADC.
Okay. Why?
I'm just gonna keep that. Then like it's not it's like I'll just do that first. Then what I would do is I would go to like do the Pythagoras theorem, and I would have got AC.
Okay.
Then again for the ABC I would do the Pythagoras theorem.
ABC or ABD? You need difference of areas of PCD and PAB, which is this triangle. PCD is this triangle. PAB is this triangle. So you want difference of areas of this.
So actually, I just have a doubt. Can we do it like it looks like a trapezium? So can you do it like a trapezium? Like first do x a plus b by 2, then we minus all of the other triangles.
Minus others, but see, your end goal is angle. You need area of PCD minus PAB. Triangle PCD minus triangle PAB. That is your end goal.
Yes.
That's the area that you need to find. How do you get that?
So can you just minimize out once? Like zoom out.
That is zoomed out, no?
Okay, sorry.
Okay, let's. Abhi has some suggestion. Abhi, can you tell what is your suggestion?
I think it will help to find the diagonals of the trapezium.
Okay, we can find the diagonals at any point. We can find the lengths of diagonals, Abhi. That's fine. What do we do with that? We'll calculate. If you ask me to calculate, we can calculate at any point. But what after? What's the next step?
Yeah, I think it's not useful way.
Okay. Any other suggestions, anyone?
Sir,
Yes, Pratham.
can we find the area of DBC and ACD and subtract them to get PDC?
Tell me again, what do you want? DPC?
Area of ADC and BDC.
ADC and BDC. ADC is this.
Yes, sir.
BDC is this.
Subtract those two and we'll get PDC.
No, if you subtract those two, PDC will cancel out. No,
sorry.
PDC is common in both.
Yes, sir.
But you're on the right track, Pratham. Good. Think something in that track, something like that, which will give you PCD minus PAB. Somehow. You're on the right
The same way we can do for the other side also, like DB and A and CA and B.
DBA and CB and these two.
No, sir. No. Yes, sir. DBA and CAB.
No, again, this thing will cancel out, but these two will remain out, no?
Yes, sir. See, but
think of, you don't want to cancel this. You want these areas, right? You want to cancel something else. And finally, you want to be left with this and this. Something needs to cancel out.
sir, got it.
Tell me.
ABC and DBC.
ABC and DBC. ABC and DBC. Okay. So you want to subtract DBC minus ABC, is it?
Yes, sir. Then we'll get AB.
So this thing will cancel out.
This thing will cancel out. Then we can do the other way around, sir.
But do we know this area, DBC and ABC? Can we calculate that easily?
We can find the diagonals.
Sir?
But
yes, one more step. Think about it. Yes, Nikhil, you have some suggestion?
AB a right angle triangle.
These two are right angles here. These two
sir,
are, nothing else is given. Yes,
we
Roy.
can get the length of the diagonal BD, sir.
Yes, you can any day calculate the length. I'm not calculating it because we might not need it.
Okay, sir. Then, sir, we can draw a perpendicular to
no, hold on. See, we've almost got the approach. Okay, we somehow, as Pratham was suggesting, we somehow need to so first he suggested if we can subtract this minus this this minus this whole area, this triangle minus this triangle, this area will cancel out. So you are left with PCD minus PAB, which is what they have asked. But the problem is we can't calculate this easily, area of this triangle easily.
Sir, one more way I found, sir.
Yes,
We
tell
can get
me.
the
We can
area.
cancel APD.
ABD. Okay.
No, sir,
So
APD or
APD.
ABP. Yes, sir.
Uh,
We can cancel out that triangle by using ABD and ADC.
ABD and ADC. Okay, so tell me properly now, Pratham, we want PCD, this triangle minus this triangle. So how do we get this? This is same as area of triangle. Which big triangle? Some triangle minus some triangle. What is that first triangle? What is that second triangle?
First triangle is a triangle DBC.
DBC, no, not DBC.
Sir, ACD.
A, correct.
ACD and ADB.
ADC minus ADB.
PD.
Good. So let me just spell it out for those of you who are getting this. ADC will split as ADP plus DPC, right? So this whole triangle we can split as this this half triangle plus this half triangle, right? Which is ADP plus DPC minus ADB is same as ADP minus APB, right? Or they have given PDC and PAC. So ADP and ADP cancel out, right? This triangle is common, the area here is common, and therefore you are left with this DPC minus PBA, which is this minus this. Yes, I hope you understood that. Okay, good. So that was observation. Somehow we cancelled, we take a bigger thing and we find something which is common, and these are easy to calculate, right? ADC, this is a right angle triangle. Area of this is half of base into height. How much is this? Half of 18 into 8 minus half of 8 into 6. How much is that? Can someone tell me how much is this? Come out
So
to me.
72 minus 24.
Is it 72?
Sir,
72 minus 8 3s are 24. How much is that?
48.
48.
48. That's the answer. Okay, so the critical part was just observing this, that this is same as this. Once you observe that, it's just one step. Okay, so
Sir, it is
usually
not 72, sir.
it's not 72.
Is it
It is 54, sir.
54. Okay,
Yes.
I'm not
54
bothered
minus-
about calculation. Okay, don't worry too much about that. That is your headache.
54
54 minus 24, which is 30. Is that the right answer, Pratham?
Yes, sir.
Yes. Okay. Good. Okay. Good. Glad you could solve this. Okay. Let's go to one more question. In the adjoining figure, we have semicircles where AB is equal to BC is equal to CD. The ratio of the unshaded area to the shaded area. So it's sort of not too complicated. Try this. Okay.
So which is the unshaded area? There are two.
The total unshaded area.
Okay.
Okay. Okay, we have some suggestions. Abhi, you raised your hand. You want to?
Yeah, I think we can start by like marking A, B, B, C, and C, D as X.
Okay.
We can
So,
find the, yeah, we can find the area of the big semicircle and the area of the tiny semicircle and subtract them.
big plus tiny. How much is this?
Minus tiny.
How much is the area of big semicircle?
It's pi r squared by 2, so it's pi into 3x squared by 2.
Pi times 3x whole square by.
Yes.
Is this right or have I made a mistake?
So yeah, it's right, but I don't think
Radius, no? I have taken diameter here, 3x.
Oh yeah, so it's
Correct.
x by 2.
So it is 3x by 2 whole square. Okay. What about the tiny semicircle? Half of pi.
Yeah,
How much is
so
the
I
area?
think we need to subtract the areas because that will give us the shaded area.
Oh, from that you have to subtract the big. Correct. Sorry.
Yeah.
So from the big semicircle, if you subtract the small semicircle, will that give you the? That won't give you the shaded area, no?
Okay, we can find big minus the
Medium sized one.
medium. Yes,
Yeah,
that
middle
will
size.
give us that part of the shaded area, non-shaded area.
Okay, so the big minus the medium will give me the one in red. Okay.
Yes.
What about the one in yellow?
Then
That will be the medium minus the small one, right?
Yes.
Okay. So how do I find the ratio of the shaded to the how much is the total shaded area?
It is B minus M plus M minus S.
This plus this, right? Which is B minus S, right?
Yes.
Okay, good. And now you need the ratio of unshaded to shaded. So area unshaded is B minus S. What about shaded?
It is no. The shaded is 2x minus the medium minus S.
The shaded is medium minus S, but the unshaded here we made an error. This should be just S, right?
Yes.
So we'll get B minus M plus S, right? So we'll get B minus M plus S by M minus S, which is equal to half of. All that half will cancel out, right? In the numerator and denominator. It doesn't matter.
Yes.
So we'll forget about the half. Even the pi will cancel out.
Yes. Even
So
the x's will cancel.
x square will also cancel out, right? So what are we left with? We just need to see the ratios. Big is 3 by 2 whole square. Is that right?
Yes.
Minus, how much is m? Tell me.
It's x 3x. No, it's
This, how much is the diameter of this?
it is 2x, so the
2x.
radius is x.
2x is x, right?
X.
Which is 1 square. Correct? All the
Yes.
x's also are cancelled out. So 1 square plus small. How much
The
is the small?
x
How much is the
by 2
radius?
whole square.
Yeah, which
It
is
is
half.
1 by 2 square.
Half square, right? Divided by denominator is 1 square minus.
1 by 2 square.
Okay. So you can do the calculation. You'll get 9 by 4 minus 1 plus 1/4 divided by 1 minus 1/4. And whatever answer you get, that's the answer. Okay, I'll leave it to you. Good. I'm glad you could see how to solve this. Okay. Yeah.
I'm sorry, but what is B, M, and S? Like I didn't know.
E was the big circle, M is the medium-sized one, and the S is the small semicircle.
Thank you.
Pratham, you won't get a pi in the ratio. The pi, I don't know how you got a pi. All the pi's cancel out. Okay. Is there any answer? 3:5? No. Not sure. Okay, let's do the next one. Let's go to the next one. Let's do this. We have still more questions to solve. So this is actually a slightly simpler one. So I'll leave this to you. But just note down the question. There's a rectangular sheet of paper. The length is 33. Okay, so the length of this is 33. Okay, and it is rolled along its length so that the width becomes the height of the cylinder. So you'll get a cylinder, something like this, and something like this, and the width will become the height of the cylinder. So this height will be same as this height. Okay, so this will be your cylinder. Now what is asked? The volume is given, the width of the rectangular sheet. The width you need to calculate. So just take the width as some x. How much will the volume of this be? Anyone? Anyone wants to answer? How? This is an easier question.
Sir, we can take the radius of the top circle as 33 by 2 pi.
Correct. This length will become the circle, right? So as you roll this,
we need to find the radius.
Along the length, this length will become the circle. This height will remain the same. So this height is x. The radius of this 2 pi r, the circumference will be 33. From there you'll get the radius. And what about the volume?
Sir, volume is the area of the top surface into the height. So the area of the top surface will be equal to x. So the area of the top surface should be equal to pi into 33 by 2 pi into 33 by 2 pi.
Correct.
Into x.
X, which is given as 1386. and then you can do the calculation. Okay, R is known from here. X is the only variable in this equation you can solve. It's important to do the calculation and finish the problem. Okay, I'm not doing it here because I don't have time. But in an exam, you can't leave it midway and say, I've completed the question. Okay, the last few steps are important and practice is very important. So unless you do this, you won't figure out how to do it in an exam quickly. So please finish the questions later after the class. Okay, 1 minute. Let's try some other questions. Okay, let's try this question. The side of the square is given as something like this. Okay, this is the length of the square. The area of the unshaded regions, this area is given as this. This pi minus 2 by pi times a. So you need to calculate the value of a. Any suggestions, anyone? Yes, Abhi. You can raise your hands if you have any suggestions, anyone. Ninada, yeah, go on.
We could like do this. Sorry.
Can I?
Yeah, Varshini, go on.
Sir, we'll see that the diagonal of the square will be equal to the diameter of the circle.
Good. So you notice that.
And we can find the area
hold on. Let's go step by step. The diagonal, you said the diagonal is same as the diameter. Good. So the diagonal here, how much is diagonal? Root 2 times the side length, right?
Yes.
Which is root 2 times root of 2018 upon pi. Okay, this is the diameter. So how much is the, yeah, go on Varshini. Now we need to find the area of the unshaded region, right? How do we find this area?
Sir, now we can find the area of the circle first because we know area is pi r square or pi d and we know the diameter and pi is a constant value. So we can find the area of the circle. And
Pi r square minus a square, right? That will give you the area of the unshaded region, which is pi times. Let me for now not use this value. Let me just use this is diameter. So radius will be diameter by 2, which is root 2a by 2, which is a by root 2, correct? So the area of the unshaded region is pi r square minus a square, which is pi times a by root 2 whole square minus a square, right? Which is pi by 2 times a square minus a square, which is a square times pi by 2 minus 1, right? I think this should become 2. I'm not very sure. Let's see. Okay, so now this is given to be pi, this thing, if I simplify, this is pi minus 2 by pi. No, okay, let me not simplify. Pi minus 2 by pi times a. This is the given area, right? Which is equal to a square into pi minus 2 by 2.
Yeah.
Yeah. So what will happen here now? Are you following? Is there any issue till now? No? Okay. Varshini, you want to tell what to do now? This is the given area. This is the area we calculated. So these two pi minus 2 will cancel out, right?
Yeah.
So you have a is equal to a square into pi by 2, correct? Which is a square is 2018 by pi into pi by 2. So how much is this? 1009.
9.
That's the answer. That's the final answer. Good, good, Sashmit. Good, Roy. Okay, just a few more minutes. So let's see if we can solve another 1 or 2 questions. ABCD is a square. E is 1/4 the way from A to B. E is 1/4 of AB, and similarly F is 1/4 of BC. X is the center of the square. Side of the square is 8 centimeter. Then the area of the shaded region, this is required. Yes, Sashmit. Suggestions?
No, sir. My hands were raised like
Last time. Okay.
yeah.
Anyone else? Suggestions? Ninada, you want to answer?
Yeah.
Yeah.
So we can do like an imaginary perpendicular from E all the way reaching X. So like
From
make
E to X. From where to where?
like until the line of X, just like a perpendicular to make a right angle triangle.
From which point to which line, or which point to?
E to the midpoint, like not exactly touching X, but directly like a straight line from E till X.
E to X is already combined, no? This line is given.
Not
No,
like
sir,
that.
you
Like
seem to drop an altitude.
yeah, like an altitude. Exactly. Thank you.
Somewhere, something like this.
Yeah. So that it will be like a proper right angle triangle. No, not like that. Like so like how should I say it?
Sir, he means that drop a perpendicular to BA from X.
The opposite side, from here to here, you want me to drop a perpendicular?
No, it's like if you are just bring a straight line from E, sir, like directly down from E, then I will tell you where to stop.
Here.
Yeah. Like the midpoint of the square will be X, just like yeah, like
This
that.
is
Yeah.
the midpoint. Okay.
Yeah. So that triangle there, and the same way over there, all the way across. Yes.
Okay.
That time you'll get a rectangle there.
Okay. Let me name these points: A, B, C, D, E, F.
Thank
G.
you, sir. That's what I was trying to tell.
Okay.
Then now you can make you
any
can take
other
the
perpendiculars? Now we can calculate this area for sure.
yeah.
How about this area? How do you calculate this area?
We can tell it as 4 into 4, and then
Hold on, Ninada. Let's see. Others. Prathamya.
One more idea.
Tell me.
The plan is from X to B, we have to draw a line.
X to B, you want to draw a line, okay?
And split this whole shaded region into 2 parts.
One is this
EXB
triangle, one is this
and
triangle.
XBF.
Okay.
So we know that the height of XBF is 4 centimeters.
Okay.
X is the center. And
okay.
same goes for XEB.
So Pratham is saying we don't need to do so many divisions, just 2 divisions are enough. Let's divide, let's just connect X to B and we get 2 triangles. So area of the first triangle, how much is area of the first triangle?
Sir,
EBA.
for the area of the first triangle, we need EB, which should be 3/4 of 8.
How much is that? This is 2, so this will be 6, right? Total is given as 8.
Yes, sir.
Yes.
So this is also 2.
So half into 6 into 4 will be the area of EBX, and the
EBX
area
is half into 6 into
into
height, which is 4.
4.
This is, sorry,
4.
this length is 4, which is the height. Good. Similarly, what is this length?
It is also 4 centimeters, sir.
This is also 4. Okay, because this is given as the center,
Of
this
a
is just
square.
half of that. Correct. So area of triangle XBF will be half of, how much is 2 into 4, right?
2 into 4, yes, sir.
So how much are these areas? 8. This is 4, and the above one is how
12.
much? 12.
12.
So together we have 16.
16 square centimeters.
Good. Good, Om Singh. You also got the answer. Good. Okay. I think I don't know if we have time for one last question. Yeah. This is an easy question. Let's end with this question. ABCD is a rectangle. E and F are midpoints of CD and AB. G is the midpoint of AF. So basically, this is 1/4 of the whole length. The ratio of ABCD to AECG. Basically, if you can take this length as the whole length you take as 4, half of that will be 2, 1/4 of that will be, this will be 1, this will be 1, this will be 2. Okay. You can take a x again, but since it's proportional, doesn't matter. Okay. Yeah, Ninada, you want to say? Yeah.
I just have a suggestion. What if we divide that shaded region into 2 parallelograms?
2 parallelograms. You want to divide it. Can't you directly find the area of this parallelogram, Ninada?
Sir, I have an idea,
Yeah.
sir. Sir,
Yeah, hold on, Pratap.
Sir,
Yes, Abhi. Can't hear you, Abhi. Someone else has any suggestions? Siddharth, you're trying to speak. Abhi? No? Abhi, Ninada, Varshini? Yeah, no idea. Can we find the area of this trapezium?
sir,
Yeah,
sir, can I answer?
yeah, tell me.
Sir, but we know
Sir,
the
we can
height.
find the area of the larger rectangle,
Area of the larger rectangle. Okay, how
and
much
then
is
we
it?
can find the area of the 2 smaller rectangles.
2 smaller rectangles. Where are smaller rectangles here?
Sorry, 2 smaller triangles,
2 smaller triangles. Okay,
CGB and AED. Then
correct.
subtract it from the
That will
larger
give you area of the shaded.
area of
But
the
is
shaded
there a
region.
is there a direct way to find the area of the shaded region?
So, it's just like a suggestion. What if we just directly take is the breadth given or width
No,
given?
I've taken breadth as B. Width you can take it as 1x, 1x, 2x. Okay.
Oh, okay. So then you can directly take the area of this one as area of the, what is it called? Area of the
Trapezium.
parallelogram as 2x into B.
Do you
2x
know
into,
how to find this area? This
no,
one,
I'm not.
AG.
AG. Let's see.
This
AGC.
Sir, it
is
will
called
be
a
Yeah.
east
trapezium.
of
Like
ABCD. minus the area of A.
Correct. That is there. Is there a direct formula? Half of height into sum of opposite sides. Have you
Sir,
heard of
we,
Yeah,
sir, sum
like
of the parallel sides, half
sum
of
of
the height,
parallel sides plus half?
L1 plus L2,
yeah.
Correct.
half times
So
height.
here you'll get x plus 2x, and the height is just b, right? Breadth. So this area of ABCD to area of this. So that is breadth into width is in this 4x, right? So b into 4x divided by half of b into 3x. So
Sir,
b
B
into
should
x
get cancelled.
x also gets cancelled, no? So you're left with 4 by half into 3. How much is this? 8 by
8 by 3.
Okay, so that is the ratio. Okay, we shot 2 minutes extra, which is fine. Okay, thanks for attending today's session. So, by the way, these are all previous, I think, questions which have come in the last 4 years in NMTC.
Can we get a PDF of these old questions?
Yeah, so in tomorrow's class, we'll tell you somewhere where there's this portal where you can go, and we will upload the questions there and you can have a look. Okay.
Okay, thank you.
Thank you. Also, this video is available on YouTube. So those of you who are watching on YouTube, you can, if you liked, please put a like and subscribe for this. Okay. Thank you all. Thank you for attending today's session. Thank you for participating. I really enjoyed. Tomorrow there will be we'll be covering number theory. Tomorrow there are 2 sessions, and over the 3 weeks we will cover most of last 4 years problems, and you will be good to go for NMTC. Okay, bye.
Yes,
Bye,
sir.
sir. Thank you.